Start.
So, hello
So we are
guys.
going to solve this question for today. Let's get started.
Okay. So, guys, in this question, first of all, we need to understand that, like, at what condition capacitor allow the instantaneously change in the voltage. In generally, capacitor not allowed to change the instantaneous voltage, but in the circuit it is allowed. So there is two conditions for the capacitor. If the finite amount of the current is flowing through the capacitor, then not change the voltage instantaneously. If the current flowing through the cap is infinite, that time capacitor change the voltage instantaneously. So let's understand these things in this circuit. So suppose this is T1, this is T2, T3. So let's understand what happened at T1 minus. T1 minus cap was, suppose this is VC1, this is VC2. Both cap are uncharged. That's why the there is a short circuit between the cap. Charge capacitor always short circuit. And then this V in voltage is initially it is zero, but that's why V out is zero only. But now at T1 plus, what happened? V in become 3 volt instantaneously, and initial cap was discharged, so it is short circuited. So basically, you just applied 3 volt directly to the ground. So that's why the infinite current will go through the short circuit. So because of that infinite current, these capacitors change their voltage instantaneously. So initially it is 3 volt, and these 3 volt divided in between these capacitor according to their capacitance. So here I took the both the values same, so that's why the that voltage is divided in between by half, so in by 2 only.
So
So
basically, what will happen if we take it C1 and C2? Can can we apply conservation of a charge?
yes, yes. So basically, if you take like C2 and this is C1, so this is V in the voltage across the VC2. If I'm considered, then it is just C1 divided by C1 plus C2. This is the voltage VC2. But here both voltage, this is V in. These things is come from the uh, infinite large current is flow through the capacitor. So capacitor change their voltage instantaneously. Because of that, these things is happen.
So we are basically applying conservation of charge.
Yes.
Okay.
So let's think this is the 3 volt. So suppose I am drawing the here input. So this is 0 only, and this is V in by 2. I'm saying that is the 1.5. So V out is V. This is the V 1.5 only. So this is 1.5. Then after 1.5, what happened? This V1 start charging, and this 1.2 it start discharging like that. And this is charging. So we see one this voltage across the C start charging and is trying to reach the 1.5 or 3 volt only. And once it is reached 3 volt, so then it will be open circuited. At the same time, this VC2 start decreasing. So it's become like this only. At this instant, VC1, this capacitor will charge the 3 volt and this discharge to 0 volt. because of the uh, output, if I'm right, V out equal to V in minus VC1. If VC1 is increase and V in constant, again then this should be decrease as we discussed in the first video. So here what happened, again input is instantaneously become 0. So this is already charged. If I'm talking about T, let me, okay, T2 minus T2 minus what happened, V in is 3 volt, VC1 is 3 volt, VC2 or V out equals to 0. This is short circuit basically. If it's 0 then this is short. Now T2 plus, what happened T2 plus? At T2 plus, this is 3 volt, so it's basically the circuit become like that. Let me draw here. Circuit become like this. This C1 and this is C2. Suppose this is the ground, this C, and initially it was charged to 3 volt, and this is voltage is 0 only, and this I make 0. Because of that, again, infinite large current flow through these capacitors, and this 3 volt divided between this cap and this cap. So this become 1.5 only. And polarity is will like that only, like this would be, because this is the high, so this will be 1.5 only. So this capacitor voltage is, and this is the ground, this become 1.5, so this is minus 1.5. This, across this suppose this is C2, this is 1 dot minus 5. So what happened here, this is 1.5 minus ka 1.5, I'm writing 1.5, sorry for being something. Input become 0 here. So initially this is C1, this is C2 suppose, and I'm just taking this C1 equal to C1 C2 and equal to C. So this is 3 volt only and this is 0. So that's why infinite large current is flowing through like that. And this voltage is divided in between, that is the 1.5 volt again. So polarity is like that, 1.5 in this direction. So this become minus 1.5. So in the waveform, I'm drawing these things. So instantly the VC voltage across this C1 was 3 volt. Then instantly it's become 1.5, and after that it will decreases to 0 because it will discharge, and the voltage across this C2 is minus 1.5 here, and it will also decrease and discharge to 0. So finally this voltage become 0 only, like that. This is 0 and this is 0. So output is basically become 1.5 to 0, then minus 1.5 to 0. When rising pulse is coming like that, then output is 1.5 to 0, and when falling pulse is coming at the input side, then it's become minus 1.5 to 0. Thank you.